Hello everybody, welcome back. In today's video, we are going to be proving the area formula for a trapezoid. So a trapezoid has some properties that you may or you should already know. If you don't, check out my other video. But a trapezoid, the properties that you need to know are that the bases are parallel to one another, and then it also has a mid-segment, and the mid-segment is defined to be, of course, the midpoint located at the midpoint between the two legs. And it's also defined to be equal to the average of the sum of the two bases. Okay, the area formula for a trapezoid is base 1 plus base 2 divided by 2 times the height. So our goal for this video is to prove that the area equals this formula. All right, before we prove the area, let's go ahead and prove our midpoint formula. Let's clear this. So we're focusing in on our midpoint formula. Let's prove to ourselves that it equals base 1 plus base 2 divided by 2. So how can we do that? Okay. Let's draw a diagonal going out from that endpoint through our segment and all the way down here. Let's also extend this line out. And I hope you can see that we have two triangles here. Here, I'm going to outline them in green. Maybe make it a little easier to see. So we have, here we have some triangles in question that I'm highlighting in this green line. Let's pay attention to these triangles. These green ones here. Okay, first, now this isn't going to be a vigorous proof, but I just want to talk you through it so that you can understand the formula to be true. Whenever I was in math class, I never liked just using a formula blankly. I always wanted to know where it came from, so I'm hoping to do that for you now. So paying attention to these triangles, well, by definition of mid-segment, we know that this side here must be congruent to this side here. We know by vertical angle theorem that this angle is congruent to this angle. And we also know that since these lines are parallel, then by alternate interior angle theorem, that these angles are congruent. Therefore, by our angle side angle postulate, these two triangles are congruent. Okay, now that we've proved that these triangles are congruent, how can we use that information to prove that the midpoint is equal to base 1 plus base 2 divided by 2? Well, since congruent parts of congruent triangles are congruent, you might be familiar with that as CP/CTC, congruent parts of congruent triangles are congruent. That tells us that this top side and this bottom part are the same length. This top side is, of course, our base 1, and so this bottom length is equal to base 1. Now, I want to highlight another triangle for you guys. I'll highlight it in pink. It's going to be the same long diagonal of this green one, and then it's going to go out here and all the way over. So our pink triangle is this big mumbo jumbo here. We have this big pink triangle. This is what we're paying attention to right now. So our mid-segment, again, this line here, well, what is it? It's also the midsegment of this pink triangle. And it might have been a long time since you've used this theorem. I have another video on it that will be linked in the description below. But by the triangle midsegment theorem, the middle section is going to be 1/2 of our full bottom length of our triangle. And in this case, the bottom length of our triangle, well, what is it? It's our full base 2 plus our base 1. Therefore, we know that the midsegment is equal to base 1 plus base 2 divided by 2. Excellent, excellent. Now that that's clear, now that we know that the midsegment is the average of our two bases, let's talk about why the area is equal to, base 1 plus base 2 over 2 times the height. Okay, so let's draw another trapezoid. Here we have some trapezoid. And let's go ahead and sketch the midsegment. Here it is. We have our midsegment. Now, how are we going to prove that the area is equal to base 1 plus base 2 divided by 2 times the height? Well, let's draw a few more lines on this picture. Here, we're going to draw a vertical line here. And let's connect these. And let's draw a vertical line here. So we're dropping verticals at the endpoints of our midsegment. And notice that we're kind of forming this green rectangle shape. Okay. So I want us to pay attention to these triangles. Oops, I thought that was my line tool. Let me go to my line tool that I'm going to outline in pink here. So these triangles that I'm outlining in pink are on both our left and right hand sides. Let's pay attention to the one on the left hand side just because it's a little bit bigger. So these two triangles, let's prove that they're congruent. Okay. Again, by definition of midsegment, this line, this side is congruent to this side length. And then also by definition of midsegment, whenever I dropped my vertical, this line must be congruent to this line. By vertical angle theorem, this angle is congruent to this angle. And so we have by side angle side that these triangles are congruent. Because these triangles are congruent, you can maybe imagine flipping this blue triangle up and filling it in here for this area. And we can do the same logic on the right hand side and fill in this area here. So we kind of shifted our shape from a trapezoid to a rectangle. And we know that the area of a rectangle is, of course, our base times our height. Okay, well, the base of our rectangle is the length of our midsegment. And the height is just our height. It's h. Okay, so the area of our blue rectangle is our midsegment length times our height. Let's check out our area formula for a trapezoid. We just proved up here that midsegment was equal to base 1 plus base 2 divided by 2. Therefore, our area does equal this formula. And that is why your trapezoid area is base 1 plus base 2 divided by 2. I hope you found this explanation helpful. Let me know down in the comments below. Hit that subscribe button, and I'll see you in the next video.